Okay, I think we're ready. This talk is entitled Microservices, the good, the bad, the ugly. And the motivation is we have a GemTalk customer that is talking about it and saying we need to move to microservices. And so it's kind of, well, I guess I should try to understand some of what are microservices. And then the ESUG call for presentations actually starts out with the following topics would be of interest. And they list microservices as the first thing. So I thought, well, there you go. I'm going to talk about microservices. You might see a little bit of a hint of where I'm going with the agenda, the Gartner hype cycle. So that will be there. But then look at the history of modularity. What is this monolith that people are comparing to? Serverless computing that was some of the inspiration. Then microservices and what might Gemstone contribute to that. So the Gartner hype cycle. Gartner is a consulting group that analyzes trends in various industries, and they've come up with this model of a hype cycle where you start with some innovation trigger, then it's wild enthusiasm or hype, and gets to the peak of inflated expectations. Then when those expectations are not met, we fall into the trough of disillusionment, but then maybe some more rational analysis of slope of enlightenment leads to the plateau of productivity. You can see some examples that they're giving us on this. The most advanced one there is generative AI, which they expect now to be hitting a trough of disillusionment, and then maybe in the next couple years eventually get to a plateau of productivity. You can see a number of other things there, though the font is a bit small, but humanoid working robots is kind of down there at the beginning with the triangle that says it will be at least 10 years before it gets to the plateau of productivity. Again, this is just some consultant's predictions, so interpret that as you will. If we apply that to microservices, we can see that there was, the beginning was in the early 2010s. Martin Fowler was co-author of a paper in 2014 that discussed it. So we might say the innovation trigger was around then, where it started getting attention. And then the next couple years had the peak of inflated expectations. If you do a search for microservices on YouTube, you can find lots of presentations at technical conferences in 2015, 2016, citing Netflix and Amazon as doing great things with it, and everybody should follow their example. Of course, it's a little more complicated, and we're not all Netflix and Amazon and don't have those resources or needs. And so a lot of early adopters found that it was a bit more challenging than the gurus or consultants predicted. But that did lead to a bit more thoughtful engagement with it. Best practices, patterns matured, and people started understanding when it would be good to use it. And so at least an argument can be made that we've hit the plateau of productivity. Not that everybody is there, but at least some might be there. It's a mainstream architecture that can be used effectively. To understand microservices, I'd like to go back a little ways to just modularity. One of the early questions is always, so how is this different from service-oriented architecture, objects, modularity, and so on? Modularity, the software design principle of breaking a system into separate, interchangeable, self-contained components or modules, where each module has an isolated set of functionality, interacts with other modules through well-defined interfaces. And there's lots of value to this. Enhances maintainability, reusability, scalability, collaborative development. The early languages, Fortran, assembly, of course, does not particularly support this well. But structured programming emerged in the early 60s, and ALGOL had some support for that. In the 70s, there was an important paper on the criteria to be used in decomposing systems into modules. And this advocated information hiding. Again, those of us in the Smalltalk community ought to see where this is going. Early languages supported it. Again, Alan Kay, Dan Ingalls, and others at Xerox were following this and developing Smalltalk. Then the 1980 Smalltalk was released out to the world, and classes and objects encapsulation became bigger topics. And component-based software engineering, people started adopting that. Objects are, of course, very good, important, but perhaps a bit fine-grained, so components might be groups of objects, and where do modules fit into that? Service-oriented architecture, and then again, 2014, early 20-teens was the introduction of microservices. Package managers help support modularity, so good things there. Languages tend to include support for packages. That is not something that is in the default Smalltalk standard for packages, but we've also adopted the being able to load packages and so on. In cloud native, this is where microservices became particularly popular. So modularity gives us easier debugging, testing. The team can group the things that are working together, code reuse across projects, simplified maintenance and update. Now, microservices likes to compare itself to the big bad monolith. So what is the monolith? Well, it's a single executable that has all your code. And that's kind of how we start out. Whether you want to call hello world a monolith, it's one executable that has your code. Changes to any part of it require redeploying the entire application. So I think it's more of the deployment side that defines what is a monolith. The advantages, well, that's where you start. That's how it builds up. That's the natural evolution of a small program to a big program. And it's simple, direct, no need for inter-process communication, other distributed systems. Distributed systems are much more complicated, and if we can avoid that, it's better. The testing, you've got all your code in one place. You can do end-to-end testing directly. Performance, you're just doing function calls. It's all within the same process. No need for this distributed model of network interconnections between separate executables. And the overhead, we avoid the overhead of multiple processes. Deployment, there's one thing to deploy, and no need to interact between multiple processes. Centralized management, you again have all your code in one place and can work with it. But people find there's some disadvantages. If you want to scale this and duplicate it, you're duplicating the entire code base. And maybe you don't need to put a big application out if you just want to scale something, some part of it. Tight coupling. Again, we've got coupling and cohesion as important concepts in software engineering. And the monolith, typically by default, it's very easy to fall into a tight coupling model. And so that makes it harder to maintain all the disadvantages that come with that. And as you get bigger and bigger, there's more to learn, more to understand, too much to fit into your head. And if the deployment, again, you're deploying the whole thing every time there's a change to any part of it. That means that if any one part is broken, you risk breaking the whole thing. And it gets harder and harder to do frequent deployments. You're all in one technology. So if you wanted to try out something else, replace a different language or stack, you'd have to replace it for everything. And that can be overwhelming. So people would try to do good modular programming. And of course, we should have been doing that all along. But now we have a name for a modular monolith. And so this is where you are trying to keep encapsulation between your modules and have them communicate. So back to the information hiding idea. Whether you're using libraries or modules, you're still putting it in all in one executable, but if you keep your pieces quite separate and a limited, well-defined API, then you can work on pieces without having to understand the whole system. If you can keep a clean architecture, that's good. The modules can enforce the separations. Easier to refactor. If you do need to move something from one module to another, it's all in the same code base, so easier to refactor. And deployment, it's still a single unit, so that's attractive. And team collaboration, they can work on separate modules, again, if you keep it reasonably isolated. But there are still the internal interdependencies. If you change one thing, you might need to change the other. Single point of failure, problems in one part of the code can bring down the whole process because you're in a single process. The scaling is still coarse-grained, and it requires discipline. If you can see other people's code, it's tempting to rely on the way they've implemented things. So this tends to require discipline of not going beyond your area. Serverless computing was something that came up in the context of this, where it's not really serverless. It's just someone else is managing the server. So you might have some outside vendor that does a service of particular functions that you can call. And the vendor will increase the scale if you're making more requests. Again, much like the other cloud-based hosting environments, with someone else providing a service, you can pay as you use it. And you have something that just executes in a particular space. We can do REST APIs, real-time analysis, data processing, nice backends for web or mobile. And AWS has the Lambda functions, Azure functions, Google Cloud functions, Cloudflare workers, other types of vendors are providing this. And you don't have to do the infrastructure management. You just upload some code and it gets called and runs. So nice things. Might take a little while to spin up if it's not already running. And again, it's going to be somewhat confined and you're tied to the vendor that you've chosen. But it did inspire some of the things now in microservices. Microservices is an architectural style that the structures an application as a collection of small autonomous services, each responsible for a business capability. Again, microservices should be structured around business. Independently deployable, you should be able to update one part of the entire system, update one microservice without it affecting the other. They're very loosely coupled, communicate over the network, typically HTTP or a message queue. And we compose these things similar to your Linux or Unix command line with pipes. So you might cat a file, then grep it, then sort it, then do something else with it. So these are the way you should think of microservices. Ralph Johnson compares it to audio components. You should be able to replace your CD player or MP3 or turntable. Just unplug it, plug in a different one, and now everything else keeps going. So you should be able to upgrade, replace completely without anyone else knowing or noticing. Single responsibility, independent deployment, decentralized data management. Now, of course, the data management is where we're starting to get into some of the things that are a bit more challenging. It allows for the technology diversity. You could even have an application that calls AWS, Azure, and Google in different places, different parts of the application, as long as they just provide the service we're looking for. Fault tolerance, maybe you can still have your shopping cart working even if the reward points aren't there. And so you could perhaps degrade more gracefully if something isn't available. Typical architecture will have a gateway that receives requests, routes it to the appropriate service, independent services, authorization, inventory, customer, and so on. Each one could have its own database. Again, you're going to not be honoring the spirit of microservices if they all use the same database. Communication, REST, RabbitMQ, or some other thing. Advantages, scalability, flexibility, faster deployment. Amazon talks about a 2-pizza team. Of course, these are American pizzas, so you might have a dozen people on a team. And resilience, isolating failures. But there are disadvantages here. The complexity, many moving parts, lots of things to manage, the operational overhead. Distributed systems are complex. Data consistency. If each microservice has its own database, then how do you keep everything consistent between them? Deployment, orchestration. So there's some challenges, some comparisons, the code organization for the traditional monolith, the modular monolith, and microservices. Code could be tightly coupled or loosely coupled, or in the microservices, completely independent. Deployment with the monolith, single unit, microservices independent. Scalability, maintainability is challenging both on the one side, if you've got the big spaghetti code, it's difficult to maintain. But if you're trying to manage many different services, that can also be a challenge. Testing, are you going to test the whole application or just part of it? Team autonomy. One of the key factors in the microservices concept is the team autonomy. And so, can you get it with the monolith? Well, only if you really allow it. So, for me, the good is enforced modularity. Microservices has enforced modularity around business capability and simple to deploy each component. But distributed systems are hard. DoorDash, for example, talked about what they were doing. They had 500 services. Placing one order required touching 100 services, so 100 different microservices, and to place a single order, they measured 1,000 RPC calls. So this is making many different calls between systems. And at least from my point of view, the ugly part is the database consistency. You're going to have challenges there. So what we'd really like is enforced modularity, independent teams, independent deployment, fast, where we're doing function calls rather than RPC calls, and database consistency. So how do we get that? Well, as you may guess, since I'm here and I'm talking about it, I'm going to suggest that Gemstone gives you that capability. And I'll talk about that for just a couple more slides. Gemstone, of course, can be a classic monolith. And we heard earlier presentations describing a customer that has 140,000 classes, 2.5 million methods, 35 million lines of code. So, you know, this is definitely a classic monolith. They do have good tests, so that helps. And in a typical environment, you're going to update and install all the code at once. Modular boundaries, again, in a monolith, depend on the team discipline. And it's tempting to go look at other code. Gemstone does have zero downtime deployment. In Smalltalk, of course, classes, methods are all just objects. And in Gemstone, objects are data. And so you can install new code, commit your transaction, and the next time someone gets a new view of the object space, they will have new methods that they're calling. So we can have zero downtime deployment. We can have isolation. So each login user gets their own root of an object graph. And you could set up separate teams as separate users where they provide an isolated set of code that they can install anytime. And you can only call it through a public API. So we can enforce the team modular boundaries. Each module can be loaded into a separate user space, but still called from other places and called simply with a function call. So microservices in Gemstone could be implemented with enforced modularity, independent teams, independent deployment, fast with function calls rather than RPC, and of course, database consistency. So that is what I would advocate for someone trying to do microservices with an existing Gemstone app. Any questions? And I know I think I did 25 minutes, so we started a few minutes late, but we can, if you have questions, we can take maybe one or two.
Most people implementing microservices now, I think they don't think too much about the technology that they use in layers and where the changes then need to happen. If you take a look at Gemstone, because you have the persistence and the code writing, you don't have to change in the database, in the front end, in the back-end code. That would be a much better thing for microservices than most technology choices I've seen, I think.
Well, so the different layers. So one of the things is when we talk about layers, the traditional layered model is UI, business logic, database. And many organizations structure their application around that. Microservices tries to focus on vertical layers rather than horizontal layers. And so one team is responsible for UI, business logic, data, and from a particular business category. Now, as you say, Gemstone has the database and the Smalltalk engine all in the same place. So in that sense, you are locked in for better or worse. I think it's better, but I would say that. But you can provide a separate UI layer because, of course, Gemstone doesn't have a built-in UI. So you're still going to be getting REST type calls over HTTP. Okay, well, we have several people from GemTalk here. Look for us. We're delighted to talk about any of these things and hear your ideas. So let's go to the break.